Okay, hello algebra friends. So Ms. Pender's been starting with a math joke. I have something better. I have Snapple facts. So, hopefully I'll get this right set up. Here it is. So, what I read, or at least I think I read anyway, is 85% of people only breathe out of one nostril at a time. That's just weird. So anyway, there's your Snapple fact. All right, so today we're going to talk about inverse functions. And I just wanted to just refresh your memory a little bit. So a function, if you remember, is a relation, just a bunch of ordered pairs or a graph or an equation, in which the x values do not repeat. It's pretty simple. A relation in which the x values don't repeat. And we like functions because they behave better than non-functions. So let me give you a little example from my, well, not really from my life, but back in the day, when I used to buy Snapples one at a time, before I got smart and bought them in cases, I would go to a local store. And so when I was at the store, I would buy 2 Snapples. And so we'd run the Snapple through the UPC code, or at least I wouldn't, but the person behind the counter would. And so they'd run it through the through a little scanner, beep, and it would be like, I don't know, $1.79. So the first one's $1.79. And if I handed them a second one exactly the same, and beep, and it came out to be $1.81, that would be confusing. 2 exactly the same Snapples with 2 different prices. That's not okay. The Snapple is like the X. The price is like the Y. So if we have 2 exactly the same Snapples, they better have exactly the same price. 2 of the same Snapple cannot have 2 different prices. X's can't repeat. So if we got 1 Snapple, we get 1 price. We can't have 1 Snapple, which is 1x, with 2 different y values. That would mean this Snapple costs $1.79 and this other Snapple costs $1.81. Not okay. So we don't want our x's repeating. It creates confusion. Okay, so the question is, what's an inverse function? Well, that's easy enough. It is a relation or function. So a function, FCN, a function formed by switching the x's and y's. Incidentally, Snapple did not pay me to advertise. Okay. So, yeah, all we need to do is just switch the x's and the y's, and we are good. And it's easy with a set of ordered pairs. It gets a little more complicated with the non-ordered pair functions that we're going to look at in a minute. The notation is this, f to the negative 1 of x. And we might recall that when we had like x to the negative 1, that was equivalent to, x to the negative 1, that was equivalent to 1 over x to the positive 1. And that's true, however, this is just notation. So f to the negative 1 is not treated the same way as x to the negative 1. That's not what we're doing today. This is just a notation thing. That's it. Okay, so find the inverse. So again, an inverse is a function formed by switching the x's and the y's. Easy enough. So here is our function, which I guess I'm going to call f. And then here's f inverse. I should run an x over there, but I ran out of room. So f inverse, in other words, the inverse of x. So that means I'm just going to do 3, 2. I'm just switching the ordered pairs. 9, 5. 11, 6. 9, 8. And 5, 10. And then my question to you is this guy right here a function? In other words, it's a relation in which the x values don't repeat. So let's take a look. So we got a 3. Do we got any other 3s? Nope. We got a 9. We got any other 9s? Yep, we got a 9 right there. So a 9 and a 5 and a 9 and an 8. So here's a Snapple that cost $5. Here's a Snapple that costs $8. That is not cool. 1 x value gets 1 y value. So this is not a function. So not function. Right? So we just switch the x's and the y's and then determine whether it's a function or not. Okay, so easy enough with ordered pairs. Let's move on to graphs. So when we have a graph, it's also fairly simple to find the inverse. All we have to do again is just switch the x's and the y's. So I have some nice ordered pairs right here. These are pretty easy to find. I put them on there, nice and easy to find. So we're just going to switch our ordered pairs. So let's start with this one here. It's kind of the easiest one to switch because it's, it doesn't have anything special about it. So the ordered pair here is 2, 5. And so I want to switch the ordered pair. And so 2, 5 becomes 5, 2. So I'm just going to do 5, 2, which is right there. 5, 2. And let's do this guy right here. 1, 3 becomes 3, 1. And 0, 1 becomes 1, 0. And negative 1, negative 1. So let's switch negative 1 and negative 1. Well, it's the same thing. So when you switch negative 1 and negative 1, you get negative 1, negative 1. So it's right there. So we're just going to connect the dots here. And we go right through. Okay. And so you can see, actually if I extend this a little bit further, it'll become a little more obvious, I hope. You can see that the green line and the red line actually meet at a certain point right here, 1, 1. And you'll also notice that as we get further up here, we get further over here. And so as we get closer and closer to the origin, we actually get closer and closer, the two lines get closer and closer. And so what we might be able to discover about this is that the two lines are actually mirrored right across this line that cuts right through them, right down the middle. And this line is y equals x. So it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And it cuts the two functions so that one is the mirror image of the other. So our original function was the red one right here. So we'll call this one f of x. And in order to find the inverse, what we actually did was we flipped the ordered pairs, right? This one was 2, 5. We made it into 5, 2, and so on all the way with all the points. The other thing we could have done is we could have said, hey, we got this red function right here. We're just going to flip it over this line right here, y equals x, which is actually the way we're going to do the next graph because I didn't give any numbers for the next graph. So again, just switch the ordered pairs, and that's how you get your function. Okay, so I had a little false start up there. Things didn't quite go the way I wanted to. That's okay. We'll just move down here. All right, so again, we have a function here, and it's f of x. Oh, did I notate that? Oh, I didn't notate here. So I want to make sure that we are calling this f negative 1 of x. And there it is. Okay. So, as I said, I didn't really give any numbers on here, except for this one right here. So we're going to have to rely on our ability to reflect over the line y equals x. And it's starting right here, so we don't need to go down to the negatives. So this one's easy enough to flip. So we're just going to inverse those points right there. So 0, 1 becomes 1, 0. That's easy enough. Now the problem is there aren't any other nice points to work with. So what I would recommend is you find some kind of distinct locations. Like we can see right here, this point right here, is probably the closest point to our line y equals x. So what we're going to do is we're going to use this point right here, and we're going to reflect it right through the line out the other side. So what's this distance right here? Well, whatever that distance is, we're going to do the same distance out to here. And so we're going to make this our inverse point for that one right there. And let's kind of pick another point. We're picking an arbitrary point here. And again, we're going to go straight through here. And when I say straight through, I mean we're going to make a little perpendicular here, right? It's going to go right through in a perpendicular kind of way. And we're going to come out the other side the same distance out to here. So those two distances are about the same, at least I hope. I'm kind of eyeballing it a little bit. And so maybe those of you who are a little more artistic than I am, maybe this would be over here, maybe. Maybe your eye is a little bit better than mine. So what I see is this. And so this green is the reflection of the red over the line y equals x. And so, of course, we are remembering that this is f of x, and this is f inverse of x. Right? We just reflected it over the line, y equals x. So now, we also must remember about whether a graph is a function or not. And the way we do that is we perform the vertical line test, right? We just draw a line straight up and down, draw a line straight up and down. And if the line only hits the graph once, it's a function. If it hits it more than once, not a function. We can do the same thing with the green line right here. So let's just kind of make our lines right through here, and we can see that every vertical line that we draw is only going to hit the green line once, or the green curve once, so therefore the green curve is a function. So the inverse is a function. Okay. So again, reflect over the line y equals x. All right, so again, now we have something just kind of this odd little shape right here. And so there is our original function. So this is f of x. And again, we want to flip this over or reflect this over the line y equals x. And again, there aren't really any points for us to work with here, so we're just going to kind of eyeball this onto the other side. So actually, there's kind of a useful point right here. And we're just going to reflect that right through. Again, we're going to go through perpendicularly, right? We can't just go, oh, let's go over here somewhere. We're going to head directly towards the line right there, the line y equals x, and straight out the other side. And there we are, right about there. And we do the same thing with this point right here. And we go straight through and straight out the other side. And we're right about there. And because it's a nice straight line, we can actually kind of do the same thing right here. We can go straight through and then out the other side. So we are reflecting this over the line y equals x. And this is the inverse of this. So we have f inverse of x. Okay, so there you go. And then I got one more graph to do. And then things maybe get a little more familiar because they look a little more algebraic. Okay, so here is our function f of x. Oops, forgot to flip back to red there. So here's our function f of x. And we want to, again, flip this or reflect this right over the line, y equals x. And I made sure this time that we had a function that was going to cross over the line y equals x. So we'd have to reflect it onto the other side and cross it right here. So let's start with actually that point. So this point right here is on the line y equals x. And so when we reflect that point over the line y equals x, it just stays right there. And we're going to reflect this point through the line, comes out over there. And again, let's pick a nice point like right here. And we go right through, out the other side, right about there, I guess. And again, let's pick this nice point right here. Oh, maybe this is out here, I guess. And let's go right through, right to about there. And that should, well, I guess I'll go with this. Right here, and straight through, out the other side. So now I'm just going to connect the dots. And so this green should be the mirror image of the red over the line y equals x. And this is our inverse function. Okay, so that's finding inverses graphically. Now, finding inverses algebraically. Oh, you know, I want to go back to this. I just want to make sure that we're actually talking about a function here. So again, let's check to see if this guy here is a function. And again, we are drawing vertical lines, and we see that, yes, this is indeed a function all the way through. So the inverse is a function. Okay, so let's find the inverse of an equation. So back to the definition that we had at the beginning, and the way to find an inverse is simply to switch the x and the y. So we're going to do that. We're going to write x equals 2 times y plus 1, right? We just literally switch the x and the y. And now we don't really generally see our equations solved for x, so we're going to solve this one for y. We're just going to get y by itself. So we just do that in the usual way. Nothing tricky today. So we get x minus 1 equals 2y, and then we divide everybody by 2 so we can get y by itself. And we have y equals x minus 1 over 2, or we could say f inverse of x equals x minus 1 over 2. And that's it. All we had to do is switch the x and the y and then solve for y. So switch x comma y, that's step 1. Step 2, solve for y. Okay, same thing right here. So this is already in y equals something times x. So we're just going to switch the x and the y. The next one I don't think I wrote that way on purpose. Okay, so the question is, how are we going to break this y outside of this square root thing here? Well, we need to get rid of the square root. So the way we get rid of a square root is we do the opposite of it, or the inverse of it. And the inverse of the square root, of course, is squaring. So we're going to square both sides. Square both sides. So obviously, when we square x, we get x squared. And when we square a square root, it's like digging a hole and then filling it back in. Nothing changed, just we had what we had before. So we're squaring a square root. That means that the square root goes away because we did the opposite to it and made it disappear. So now we have x squared equals 3y minus 2. Solving for y, we add 2. So we get x squared plus 2 equals 3y. Divide by 3. And we get inverse of x, or inverse of f, equals x squared plus 2 over 3. We could also, by the way, write this as x squared over 3 plus 2 over 3, just separating the fraction into those two parts. Either way is good. Okay, again, not terribly difficult here so far, but this time I wrote it as f of x equals this. Well, we remember, of course, from back in the day that f of x is really just the same as y. So we write y equals 2x cubed plus 1, and we switch the x and the y to y cubed plus 1. We want to get y cubed by, or y by itself, so subtract 1. So we get x minus 1 equals 2y cubed. Divide everybody by 2. Kind of finish it up over here. And kind of reverse the order here. So now I have y cubed equals x minus 1 over 2. So how do I get rid of a cube? Well, I cube root both sides. So that's going to give me y equals the cube root of x minus 1 over 2. And I'll just finish it off with proper notation, if I can fit it all in there. And there it is. For once in a while, I feel like Bob Ross. Okay, so there's our inverse there. These are a little more tricky, and I'm going to jump right down to the more difficult of the two, because we're running out of time, and I want to not do a 20-minute video. So here again, we're going to start with y equals 2 over x plus 4 minus 1. And we're going to switch the x and the y, as I did before. I'm going to need more room, so I'm going to write this over here a little bit so I can have two columns to work with. 2 over y plus 4 minus 1. All right, so I want to get the y by itself. So I try to move everything over to the other side. So here I can move the 1 over to the other side, and that's easy enough. So we get x plus 1 equals 2 over y plus 4. All right, so now we have y plus 4. The y is in the bottom of the fraction. It would be great if it was not in the denominator. So we can remember, of course, that everything is over 1. And we see here that we have a fraction equals a fraction. So that's a proportion. And we solve all proportions by cross multiplying. So we have x plus 1 times y plus 4 equals 1 times 2, or 2. We just cross multiplied. Then we multiply all the stuff here by FOIL. So we get xy plus 4x plus 1y plus 4 equals 2. And again, we're going to try to solve for y, so that means move everything over to the other side that's not a y. So we'll subtract 4, and we'll also subtract 4x. Just doing 2 steps at once here. So I'm going to have xy plus y equals 2 minus 4 is negative 2, and negative 4x is just negative 4x. That's an x. So now I want to get y by itself, and I notice here that I have 2 y's, and I only want one of them. So what I'm going to do here, right up here, is we notice there's a y here and a y here. That means I could factor out a y because they both got one. So I'm going to write a y right here, and that's going to leave us with x plus 1 equals negative 4x minus 2. And I'm going to divide both sides by, oops, that's x plus 1, by the way, x plus 1, not x plus y, x plus 1. So I'm going to divide everybody by x plus 1, so we get y equals negative 4x minus 2 over x plus 1. And with proper notation, that's f to the negative 1 of x equals that. And again, I don't want to go too much longer here. So there it is. There's finding inverses. That was 21.5 minutes. So see you all on Wednesday. Be safe.